Or,
Just right now we're starting on unit 10.1. We're starting on Monday, so I was wondering if I could get on ahead of it by learning it early.
okay. Do I have your book?
Yeah, you do.
Okay.
It's Algebra 2, McDougall.
Quadratics and conic sections?
No, it's the distance and midpoint formulas.
Ah, okay. That's 10.1. Yeah. Okay. 589. Just open to it. All right. If I say, what is, hold on a moment. I'm going to have to close this out and reopen it.
Here, one sec. I'll be right back. I'm going to go get some water if that's okay.
Sure.
Thanks.
Let me try this one more time. There we go.
Okay, I'm back.
Okay. Let's talk about the distance formula. The distance between 2 points. I'm going to make one of the points 1, 3, and I'm going to make the other point 4, 6. Notice that that distance is not a directly vertical or a directly horizontal distance. So
Yeah.
it's not absolutely clear how to find it. But what it is, almost always, if it's not directly horizontal or directly vertical, then that is always the hypotenuse of the right triangle that I would construct. Okay?
Mm-hmm.
And the hypotenuse of a right triangle is always the square root of the sum of the squares of the other two sides. Well, what is that distance right there?
3.
Yeah, it's the distance between the x-coordinates. What's this distance right here?
3 also.
So what is the hypotenuse?
Shouldn't it just be like 18, the square root of 18?
Yep. Which would simplify to, I can take a 9 out of that, so it's 3 root 2. And that's the way to think of the distance formula, as you're always finding a hypotenuse. And so they give it to you as a complicated thing. One moment, I'm about to sneeze. Excuse me.
Mm-hmm. Excuse you.
Sorry.
You're good.
In other words, that's the hypotenuse of that triangle that I drew.
So it's just the Pythagorean Theorem.
Right.
So
It's the difference of the x's squared plus the difference of the y's squared. Now,
so that's pretty simple.
yeah, actually it is, as long as you remember. In other words, a lot of students will look at this and think it's something new, and they've just got a new complicated formula to memorize. But if you know the Pythagorean theorem, and this distance between 2 points will always be the hypotenuse. The only time it wouldn't be the hypotenuse is if it was a horizontal distance. In other words, let's say the 2 points, instead of being 1, 3, and 4, 6, are 1, 3, and 4, 3. Okay. Well, that's just a horizontal line. What's that distance?
3.
Yeah. So if it's horizontal line or vertical line, then you can get the distance easily. It's only if it's not horizontal or not vertical that it becomes the hypotenuse of the triangle you would create.
Mm-hmm.
Okay, let me give you a test. What is the distance between these 2 points?
Okay, so it's 36.
You don't, this is one case where if we had to figure out the slope, then it would matter which one I subtracted first. But notice that I'm going to square. In other words, all of these always begin square root of. What's the distance between the x-coordinates?
Oh, the distance between the x-coordinates. So it's 6, yeah.
And we don't care if it's -6 or 6, because we're going to square it anyway.
So 36.
Plus the distance between the y-coordinates.
4 squared. Well, 4, but squared.
How do you simplify that?
Split it into multiple parts.
Okay. Go ahead. Can you simplify it? Let me put it that way. In other words, is one of the factors of 52 a perfect square number? That's what answers the question as to whether you can simplify it or not. In other words, is this number divisible by 4 or 9 or 16 or 25?
It might be divisible by 4.
It is divisible by 4. You have 4 times 13, which means it simplifies to 2 root 13. And that's the distance. Remember that the distance formula always begins square root of. Just like if you're solving a Pythagorean triangle. If you're solving a right triangle, no matter whether you're solving for one of the short sides or whether you're solving for the hypotenuse, the answer always begins with square root of.
Okay.
Okay? Now, that's pretty straightforward, and that's really all there is for the distance formula.
So that's pretty simple.
Yeah, it is, as long as you associate it with the Pythagorean theorem. Now let's talk about the midpoint formula. Midpoint formula is even simpler. I'll go ahead and draw a picture just because it never hurts to have a picture. There's -2, -3. And there's 4, 1. Notice that when I'm drawing my pictures, I really don't care whether I'm perfectly to scale. The only reason I'm drawing a picture is to get a feel for it. So when they talk about the midpoint, they're talking about the midpoint of that line. Well, it's really easy. The midpoint of that line is the midpoint of the x-coordinates and the midpoint between the y-coordinates. So what is the midpoint between -2 and 4?
0.
Well, 0 would be 4 units away from 4, and it would be 2 units away from -2. So the midpoint
Yes.
definition has to be equal distance.
It would be, what is it? Sorry, could you repeat it again?
Between -2 and 4.
Sorry, I'm super tired today.
All right. Let me give you an easy way to do it. I really would like you to be able to kind of put it on a number line. And there's 4, there's 0, and there's -2. Well, we're looking for this point right here. Must be 1. Okay? 1 is 3 units away from 4, and it's 3 units away from -2.
Okay.
So 1 is that. Now, there's an easy algebraic way to get it, and that's to just add the two numbers together and divide by 2. Notice, yeah, when I add -2 to 4, I get 2. Divide by 2, I get 1. So what's the y midpoint? And you get that the same way. Add the two numbers together, divide by 2.
So you get -1.
That's distance formula and midpoint, and there really isn't a whole lot more to say on that.
Pretty simple.
Yeah, it is. Finding the midpoint is really simple. What might be a little bit harder would be, and this is typically the kind of problem you're going to get, where they will give you the midpoint and one end point. In other words, there's my middle, there's my end. What's this point here? The other end.
Would it just be 3, 2? Or no?
Remember that whatever it is, the x-coordinate has to be the same distance from 4 as 4 is from -2. So how far away is 4 from -2? This distance right here.
Yeah, just 1.
No, count it up on the number line. Look at it. You got to go 2 units to get to 0, and you got to go another 4 units to get to 4. So it's 6.
Oh.
In other words, I changed the problem. I didn't give you 2 endpoints. What I gave you was one endpoint and a midpoint. In other words, there's another endpoint to this line that we're trying to figure out. Well, if x has to be 6 more than 4, what is x?
10.
And how about y? How much greater than -3 is 1?
4. So it should be 5.
Right. And again, to get this, is all you have to do is take this midpoint and subtract that number. So I would have 4 minus a -2, which is equal to 6. That's how we got 6. And then I add 6 to 4 to get 10. Okay, and the same way with the y. If I want to know the distance between 1 and -3, 1 minus a -3, that's a distance of 4 units. So I'm going to add 4 to 1.
Okay.
Okay, so now you should be able to find distance between 2 points. You should be able to find the midpoint between any 2 points. And you should be able to find an end point given one end point and the midpoint. All 3 of those are potential questions that they would ask. And in fact, I can't even think of another kind of question they could possibly ask. other than the geometry connection at the end where they want you to classify the triangle as scalene, isosceles, or equilateral. You see on chapter 10 in my book, it's page 592 at the bottom.
Mm-hmm.
Okay. Notice, let's just do some of those problems. Let's find the distance between 17. On number 17, what's the distance between those 2 points? Remember, your answer is going to begin square root of.
So it's the distance between the two. So it's -3 squared and -4 squared.
And we don't care whether they're negative or positive, because once we square them, so
It's always
we don't even need to worry about whether it's negative or positive. It's not like slope. Slope is actually harder, because when you calculate the slope, you can only do it, you have to do the numerator and the denominator in a consistent direction. Otherwise, you get the slope wrong, the sign of the slope. Okay, what's the square root of this?
So it should be 9 plus 16, so 23.
25. 9 plus 16.
That should be 5.
Okay, and that you should recognize as a 3, 4, 5 triangle. In other words, here was the point, 3, 4, and there was the other point, 0, 0. If I make my triangle, this side is 3, that side is 4. If you recognize a 3, 4, 5 triangle, you wouldn't have to do any math. You could just put the 5 right there.
Okay.
Okay. Let's do one more before we go on to the ones at the bottom. Let's do number 23. The distance between -5 and -8 and 1 and 6.
All right, so you should get -6. So it's 6 squared.
Hold on. How do you start the answer with every one of these?
The square root.
Right. Don't forget that, because that'll screw things up. If you wait till the end to put it on, it's easy to not put it on. So that's why I always encourage everybody to put it on at the beginning. Okay? What's the first term?
23, right?
Well, you said -6 squared.
Yeah, so 6 squared.
Plus or minus?
Plus. -14.
Okay.
14 squared.
Yeah. And the way to get that is take that number and subtract that number.
Okay.
In other words, the second number minus the first number, or the first number minus the second number. If you do the first number minus that one, you'll get -14. If you do this one minus this one, you'll get +14. It doesn't matter as long as we get 14 squared.
Okay.
Okay, and then whatever that number is, if you have a calculator, you can do it, or you can leave it in radical form. They probably want you to leave the answer in radical form. What's 14 squared? That's
added all together, the whole thing is the square root of 232.
okay. Is that number divisible by 4? Here's how you tell the last 2 digits. If the last 2 digits of any number are divisible by 4, then the whole number is divisible by 4.
Okay.
7,448, excuse me, I didn't need that extra comma, that is divisible by 4 because 48 is divisible by 4. So we know we can break that down. We won't do that for the moment. We'll focus on our distance and midpoint. What's the midpoint between these 2 points?
So it would be -3 for the x value and -7 for the y value.
Add the 2 numbers and divide by 2.
Oh, I subtracted them.
When you're finding midpoint, yeah, you want to add them.
Oh, okay. So it would be -2 for the x value and -1 for the y value.
Okay, good. All right. Take a look at some of these problems at the bottom.
Number 57 looks interesting.
I'm sorry, what?
Number 57 looks interesting.
50?
Yeah, it's on page 593.
Okay. Let me read it. Let's see. V is the speed of the car. R is the radius of the circle along which the car was traveling. And A varies depending on road conditions, so it's just a constant. So find the radius of the skid mark shown below when using the given equation and 6.86 for A to find out how fast the car was going. So let's talk about the radius of the skid mark. I'm trying to figure out their drawing. And how this is going to affect this chapter. In other words, I'm inclined to think that they need the distance between those 2 points.
How do we find that since that's on a curve?
Well, I can certainly find the distance between the 2 points. Anytime you have 2 points in the xy plane, you can find the distance by using the distance formula.
Oh, so
subtract the distance between 16 and 10 is 26. So it's the square root of 26 squared plus 1 squared. Okay, but right offhand, I don't see how that distance tells us much. I'm trying to figure out, well, let's write the equation they gave us. They gave us V equals the square root of AR, and we need to solve for R.
And we know what it is already, too.
Yeah, when a car makes a fast, sharp turn, can use the skid mark to determine its speed. So apparently we're looking at the skid mark. But we don't know the velocity of the car. The radius of the circle, so that curve that we're looking at, we have to figure out the radius of whatever that circle would be. Which I don't have a clue as to how to do.
I have no idea either.
I'm trying to think for a second here if I can figure out how to figure out that radius. Because it's obviously going to be some distance away towards the middle of the page, right? In other words, if I were to try to complete that circle, the radius would be the distance from 0, 0 to the middle of the circle. Ah, all right. We have another equation for the equation of a circle. Wow. And that is x minus h. I don't even need the minus h. The equation of a circle is x squared plus y squared equals r squared. And we have some points that we can fill in here. In other words, we know 2 points on that circle. We know that 10 squared, negative 10 squared, same thing, plus 1 squared, that's equal to the radius of that circle, squared. And then if I plug in the other point, we have 16 squared plus 2 squared. That point is also on the circumference of the circle, so that's also equal to r squared. So 1 gives me I don't know how to do this problem. Was this one assigned as like a bonus question, or you were just looking and you saw a problem that...
I was just looking at it because
I would be surprised if they gave you this. Although, I don't know, Mullen, they might. Most of my algebra students would never come close to getting this problem.
okay.
If we could figure out r, seems like I should be able to with just one of these equations. This is what? This is 256 plus 4. That gives us a different r for each one. They both have to be on the same circle. And any point on that circle needs to fit that equation. Anyway, if we could figure out r, then we're just going to substitute r for whatever we solve it to be and put in 6.86 for a, and then we could figure out the velocity based on an a and an r.
Okay.
Yeah, that is not an easy geometry problem. I'm trying to figure out why it isn't easy. But I don't think we want to spend our time doing it. Although our time is up, so I'll have to think about that problem. I'll probably see you tomorrow. I'm coming over to the house to work with your sister
Okay.
at about 6:15. I'll think about this problem, and if I can figure out how to do it, I'll tell you then.
All right. Well, thank you.
All right, Jake. Talk to you.
All right.
Bye-bye.
Yeah.